Moving on, however, we're going to talk about a couple of different things. Now, keep in mind, the ASDM will most likely be used for a lot of these options. The problem here, of course, is that ASDM doesn't work. So we're going to have to do everything from the command line. So let's come over here into the primary, which we're still plugged into the console port on the standby, so I'm not too worried about that. However, IP access. We don't have IP access. It's not a router or a switch. So if you come in here and create access group, and then you specify the name of an access list. So let's just say this as inside. From here, the access group inside is going to be in the interface, and then it's going to be a security zone. So you don't actually choose an interface that you're going to use for this particular access group. You're going to use the security group. And a lot of the times with Cisco ASAs, mostly you're only going to be using the input command rather than output command. We'll talk about that in a moment. So in interface inside. So from here, access list inside does not exist. Okay, access list inside, and then you can do deny statements, ether type, if it's extended, the different lines, permit, rename, standard, web type, what have you. But from here, we're just going to make it an extended permit IP any. So now we can go back here and IP or access group inside in interface inside. So from here, you're going to notice that we have this new access group. Show run access group. Access group inside in interface inside. Show access list inside. This is going to be your elements. So access list inside line 1 extended permit IP any. From here, let's try access list. Apparently we have a couple of other options here. So access list inside standard permit hostname. So with standard, you don't actually choose a protocol, you just permit or deny based on the network address. So from here we'll say host 172.16.0.254. That's it. We're permitting or denying the host or the network. That's it. But you cannot mix different types of access lists. Since we've already created an extended access list, you cannot now run it as a standard. However, let's try access list inside and then permit. Because it was an extended access list, now we have to choose our different protocols. In this case, you can use a protocol number, or it gives you an option of using all the different types of protocols that are not TCP or UDP. In this case, inside permit EIGRP, any source, any destination. There you go. What else can we do? Let's see. Access-list. Let's say it's inside standard. We'll name this as a standard access list, or we can just go permit, and you're going to have your protocols. You have to specify if this is going to be standard or not when you start out. So 172.16.1.254. And we can specify a net mask, or if it's that particular host, we can list it as the host. Now from here, if we try to come in and do an extended permit IP any, I'm going to say it cannot be mixed. So let's try this. Permit question mark. But you're going to have these protocols again. So ERGRP, any, enter. Doesn't mix. So if you're going to do the permit statement without an extended or standard, it automatically thinks it's an extended access list. So keep that in mind. The next one we're going to do is an access-list for outside. Let's see. Deny IP any. Alright, there you go. Show run access list. We have our inside and we have our outside. Show run access. Let's do group this time. But you're going to notice our access group for inside is the only access group we have. So from here, we need to specify the access group outside, which is the access list, in interface. Wait, we don't have an outside interface, so that's not going to work. Well, let's try name interface. Doesn't exist. Okay, so how about interface gig 1/2? Name interface outside. Security level for outside is set to 0 by default. Let's try to create our access group again. Outside in interface, and now we have outside. There we go. Show run access group. So now everything you create inside of these access lists will determine what is able to go into the inside zone or the outside zone. Now keep in mind you can have multiple interfaces in a single security zone. So if you look here at this ASA over here, you can have 1, 3, 4, 5, and 6, and 7 in the inside interface security zone. They can all have the same security level as 100. It doesn't matter. They're all going to use the same security access group. Now this is a little different from what you might see in Cisco routers and switches. So for here we have, let's say, line 1. Access list outside. Let's see if it's there. Nope. You have to specify it every time. Permit IP any. We didn't specify a line. Show access list outside. So you're going to see here it created line 2. So let's go no access list outside line 2 in complete command. So you actually have to type it out. So we've just removed it. So let's come back over here to access list outside line 1 permit IP any. Show access list outside. What you're going to notice here is that in a Cisco ASA, when you type a line command, if that line already exists, the existing lines will be pushed out. So like in a Cisco router or switch, it'll tell you, I'm sorry, that line already exists and you can't overwrite it. In the Cisco ASA, it just renumbers them. So that's one of the really cool things about a Cisco ASA. However, let's come in here and do access list outside line, I don't know, 1000. Permit IP any. But you're going to see here that it found a duplicate element. Show access list outside. It's still line 1. So there are times where you have to come in and remove the line before you can add it or move it somewhere else. So let's see here. How about rename? So let's see. Rename line 1. Show access list. Access list 1. So you're going to see what we did, right? We actually accidentally renamed the access list outside to 1. So I would have just hosed our entire network right there. So keep in mind that is something that can happen in production you really don't want to do. So access list outside. You could rename the access list name, but sadly access list outside line 1. You can't rename the line number. So, keep that in mind. If you want to move a line, you got to remove it first. If you want to add a line, you can add it wherever you want, and everything will move on its own. Alright, let's see. Show interface IP brief. 172.16.0.1. This interface has a standby IP address. Show run interface gig1/8. This is the failover interface. Show run interface management 1/1. This is the shared management IP address by both the active and the standby ASAs. So here's a really good thing. Let's check out Packet Tracer. Is a really awesome tool you can use on a Cisco ASA. So we're going to use the Packet Tracer input to the outside interface. It is going to use TCP source address 1.1.1.1. Let's just say domain destination 172.16.0.2 domain, and then we can have output in XML format, allow simulated packet to transit from device, detailed, decrypted, treat the simulated packet as an IPsec SSL VPN decrypted, or just hit enter. This will tell us it's dropped. Interface is down. Interface is down. Drop location frame is down. Now perhaps I'll have to turn gig1/2 on and show you this. But the packet tracer command is really awesome if you have traffic flowing and you don't know if it's being blocked by the firewall or not. Now the Cisco ASA does have a real-time traffic analyzer viewer that you can use. But say you get someone and they're like, hey, my SQL server can't connect to my web server from the DMZ inside to the DMZ outside. Well, you ask them, okay, well, what's the source address? Well, the source is 1.1.1.1. Okay, what's the protocol? Doesn't matter. Maybe it's 65,000. And then you want to connect to 172.16.0.2, which is the web server. How about let's try packet tracer input inside TCP 172.16.0.10, and you really have to type something in. I don't really understand why they did that, but let's just say 65,000 because source ports are usually something out of the known port list. And this is going to be going 172.16.0.11, and let's just say this is on the 1433. So it goes through our phases. We have an access list lookup. It is allowed through the access list, because keep in mind we have an allowed IP any. We do a route lookup. There's no load balancing, so it's allowed. It also said where the destination is, locally connected, found the next hop, 172.16.0.11, using the egress interface inside. Then it looks at the access list yet again, and the result is drop. So let's see. Input interface inside. Status is up, line status is up, action is drop. Drop reason, ACL drop. Flow is denied by configured rule. Drop location. So let's look at it again. Show access-list inside. Permit IP any. Well, you gotta wonder, why is it not working? So, same security traffic, permit. Inter and intra interface. Intra. Let's try this again. Interface is down. Let's see. Alright, there we go. Route lookup, access list, NAT, IP options, failover, standby update, NAT per session. Keep in mind you have your inbound NAT and your outbound NAT. If IP options are configured, flow creation, input route lookup from output route lookup, resolve preferred egress interface. This is allowed. And the result, no version 4 adjacency, no valid v4 adjacency. Check ARC table. Well, this is probably because we don't actually have a machine with this IP address configured. However, that's one thing you really do need to remember as well. You can actually have inter and intra interfaces with the same security traffic. So say example you had on 1/1 and 1/3, they're both inside. Well, they would not be able to communicate by default unless you have the same security traffic to permit interface, which is apparently off by default. So is intra interface for that matter. Yep, I hope you enjoyed it, and I'll see you in the next one.